Linear inequalities in two variables. Differentiate linear inequalities in two variables from linear inequations in two variables. In terms of writing the equations, linear equation in two variables is written using the equal symbol, while linear inequality in two variables is written using any of the following inequality symbols: greater than, less than, greater than or equal to, and less than or equal to. Linear equations in two variables written using the equal symbol. So, this is the example of linear equations in two variables. 5x minus 3y equals 11. Linear inequalities in two variables. This is the example. We're going to use the symbols: the greater than, less than, greater than or equal to, less than or equal to. 2x plus 3y greater than 10. 5x minus 10y less than 30. X plus 2y less than or equal to 12, and 4x plus y greater than or equal to 23. The graph of a linear equation into variables is called straight line graph, while the graph of linear inequality into variables is called a half plane graph. A half-plane is confined by a line called the boundary line, which can either be a solid or a dashed line, depending on the inequality symbol used. In addition, the inequality symbol determines which side of the boundary line is to be shaded. So let's have the example first, the straight line graph. 2x plus y equals 4. So this is only an illustration. The graph of linear equation, straight line. So when we go into graph this, 2x plus y equals 4, so this is the straight line graph. So take note, straight line, that is equals. And how about the half plane? What do you mean by that? This is the example of graph of linear inequality half plane. 2x plus y greater than or equal to 4. So this is the graph. So as you can see, we have the arrow color yellow-green and the half planes that is color blue. So in this inequality symbols, there are two lines. This is called the boundary lines. So boundary line is a solid line since inequality symbol used is greater than or equal to. So there are the two lines for inequality, the dashed line and the solid line. The solid line used only for this symbol. This symbol is greater than or equal to. And the other symbol is the less than or equal to. So I'm going to write this. So the other symbol is less than or equal to. So these two symbols are the line, which is a solid line. So as if you see this symbol, you need to use the solid line. But if the symbol is only greater than and less than, so we need to use the dashed line or the broken lines. So dashed line and the broken line is same. Dash line. Okay. So now, so you know how to use the dash line and the solid line. Now for this one, for the half plane. So this is the half plane, the blue. The shader region is towards the right side since all points in the side will satisfy the given inequality. So it means, so this color blue is the solutions of the given inequality. So take note. So if you get the points here. So that is the solution for linear inequality. So let's go on. Let's have the activity. Write if the given is a linear equation into variables, I if it is a linear inequality into variables, and n if it is neither of the two. So I show you first activity 1 to 5. So let's have the number 1, 2x plus y greater than or equal to 7. So the symbol is about an equality symbol. So it means this letter I. That's the answer. For number 2, we have the equal symbol. So equal symbol, that is the equation. So that is linear equations, letter E. For number 3, we have the x equals 4y, although there's no symbol for C, so it means we need to use also the letter E. The equation, just because of the symbol equal. For number 4, we have the x minus y less than 3. Less than is inequality symbol, therefore that's I. And number 5, there's no symbol, neither of equals or inequality symbol, so there's no symbol, it means that's letter N, so neither of the two. Alright, so let's have the number 6. 6 to 10. So 6, 3x less than or equal to y. 7, 0.5x plus 0.5y equals 2. And 8, 8x minus 7y greater than 15. 9, x squared plus y equals 1. And 10, 2y equals 3x plus 10. Let's have the number 6. This is less than or equal to, so it means that's letter I. This is equal symbol, that's letter E. For number 8, we have the greater than symbol, that's for inequality, letter I. But for number 9, as you can see, x squared. So for linear inequality, the degree must be 1, or the exponent is 1 or the first degree. So it means this is a quadratic equations because of the equal symbol, and for the exponent is 2. Therefore, we need to write the letter N, neither of the two. And number 10, 2y equals 3x plus 10 equations, that is letter E. Let's have another one, some samples of translating sentences into equations. For letter A, according to PSA, male Filipinos, the symbol is M, are less than the female Filipinos, symbol is F. Now we're going to write this equation into equation. So these sentences, we're going to transform into equations. So we have the symbol for male, that's M, and female Filipinos, F. Less than, so this is the answer. Male less than female, or M less than F. So that's the answer. Let's have another example. The value of $1 is greater than the value of 1 Philippine peso. So we can use the U for US dollar and greater than symbol and then the value of 1 Philippine peso. So this is the answer. 1 USD greater than 1 peso. You can write the whole word, the 1 US dollar and the symbol of this one, and 1 Philippine peso. So that's the same answer. Another one for letter C, the elevator in the mall has a maximum capacity, that's for letter C, of 10 persons. And this is the answer. C less than or equal to 10. Why is it less than or equal to 10? That's why, just because of maximum capacity. So when we say maximum, so we need to use the less than or equal. For letter D, to get a passing mark in school, a student must have a grade G, this is a symbol, of at least 75. So what do you mean by at least 75? So this is the answer. G greater than or less greater than or equal to 75. Again, G greater than or equal to 75. When we say at least, that is greater than or equal to. Another example, determine the solution of linear inequalities. So it's all about the linear inequalities. We're going to determine the solution, but how? So this is the step. We have the example, determine if the points 3, 2, 0, 0, and 2, 0. So sa past lessons for the first grading, so we know this one, the 3 and 2, this is the coordinate points or ordered pairs. The 3 and 2 is the x, y. So 3 is for x and 2 is for y. Just the same for 0, 0 and 2 and 0. Our solution of 2x plus 3y less than 6. So these 3 points or these 3 ordered points, we're going to find the solutions for 2x plus 3y less than 6. If this ordered points is a solution of these equations, or this one or the other one. So note, to determine the given point is a solution of an inequality or not, substitute the coordinates in the inequality. So let's have the given example. So this is the equations, the linear inequalities, 2x plus 3y less than 6. Let's have the first one. The ordered pairs is 3 and 2, and this is x and this is y. So we're going to substitute the x into this and the 2 into this one. The 3, this is for x, and the 2 for y. Okay, so let's have this one. 2 times 3 plus 3 times 2 less than 6. Okay, after that, we're going to multiply 2 times 3 and 3 times 2. So we have 6 plus 6 less than 6. And we're going to combine the 6 plus 6, that is 12, less than 6. Okay, as you can see, the 12 less than 6, is that true or false? So it means that is false. Because 12 is greater than 6, not 6 is greater than 12. So it means this is not solutions of these equations. Let's have another one. 0 and 0. So this is x and this is y. Again, we're going to substitute 2 times 0 plus 3 times 0 less than 6. Multiply and multiply this one, so automatic that is 0 plus 0 less than 6. So the answer is 0 less than 6. So is this true or false? Yes, just because 6 is greater than 0. Right, so we have a solutions for 0 and 0. So this is the solution. How about the other ordered pairs? The 2 and 0. Is think this is the solutions of these linear inequalities? Let's have this one. This is x and this is y. Again, substitute the value for x. X is 2 and y is 0. So 2 times 2 plus 3 times 0 less than 6. Then multiply this one. 2 times 2 and 3 times 0. So 4 plus 0 less than 6. So 4 plus 0 is 4 less than 6. So is this true or false? Yes, it is true. Why? Just because 6 is greater than 4. So it means these are true are the solutions of 2x plus 3y less than 6. Graph of a linear inequality into variables. This is our first example, the x minus 2y less than 6. This standard form we're going to change first into slope-intercept form. So do you remember the slope-intercept form? So this is the slope-intercept form. The y equals mx plus b. So we need to get the m, or the slope, and b for y-intercept to graph the linear inequalities into variables. So let's have another one. So next step. Negative 2y less than negative x plus 6. What happened for this one? So we're going to change the x, this one, to the negative using the subtraction property of inequality, or in shortcut you need to transpose the x into the other sides, or to the right sides. So this is the left side and this is the right side. So when you transpose x, it becomes negative, so that's why it becomes negative x. And the other steps, negative 2y less than negative x plus 6. We need to get only the y here, positive, not negative. Therefore, we need to divide both sides this one into negative 2. So, negative 2 to the left side, to the right side. And then after that, we need to cancel out the negative 2. And then let's have the form for the slope-intercept form. Y greater than x over 2 minus 3. So as you can see, the symbol here is interchange. Why is it interchange? Because when we divide negative 2 both sides, so we need to interchange the symbol. Less than becomes greater than. And negative to negative, that is positive, so just simplify it. So negative to negative in dividing, that is dividing of the integer, that is positive. So 6 divided by negative 2 is negative 3. X over 2 is 1/2, so therefore m is 1/2 and b is 0 and negative 3. Why is it happens to 0 and negative 3? As you can see, the b here is the y-intercept. So let's write the y-intercept. When you say y-intercept, the x is 0. Okay, so therefore the 0 is for x and the y is a negative 3. So we're going to graph this one here. Okay, we have the take notes. The graph inequalities. Inequality symbol, the type of line is the dash line, and for greater than and less than. Take note of this one. This is both dash line, but they are different from the shaded. For the less than, we have below shaded form, and for greater than, we have the above shaded form. For the solid line, we have this symbol, and they are different only for shaded. If this is symbol, that is below shaded. If this is symbol, this is above shaded. So we're going to clarify that later. So this is the graph. So we're going to graph the m, that is 1/2, and b, that is 0 negative 3. So first we're going to graph the 0 and negative 3. The 0 and negative 3 for the y-intercept is here. So that's the points. And then for m, that is rise over run, right? We're going to up or rise 1. From the start here, let's count 1 and run. Because that is positive, we're going to right. So let's count from start here, 1, 2. So therefore, another point is here. Again, let's graph first this one, 0.3. Let's plot first the 0 and negative 3. That's for y-intercept. So this is 0 and negative 3. And then for the M, for 1/2, 1 is for rise and 2 is for run. So we're going up 1, that is 1, and then for going to the left, because that is positive, we're going to count 2. 1, 2. So therefore this is another point. And then let's use the line of dash line. Why we need to use the dash line? Because in graph inequalities, if the symbol is greater than or less than, we need to use the dash lines. So that is the dash line. So this dash line is called the boundary line. Alright, even if the solid, it is boundary line. So we use only the dash line because of the inequality symbol is greater than and less than. Okay, now we're going to, the problem is how to shade to find the solutions of this linear equality into variables. So this is the symbol, the greater than. So the greater than, the shaded is below, is above. Okay, so take note, it interchanges the sign, the symbol. So if the symbols interchange, we need to follow the last symbol. So this is greater than. So if it is greater than, so it means we need to shade above the line. So let's shade above the line. So it means this shaded form, the shaded part, is the solutions, or are the solutions of the x minus 2y less than 6. All right, so let's have another one. Okay, the graph of linear inequality is called a half plane, and it's a bounded line called boundary line. X plus 2y greater than or equal to 6. Okay, let's have this one. Using x and y intercepts, we're going to graph this also. But another way how to graph. So we can use two ways. That is forming a slope intercept form. You just get the m or the slope and the y-intercept, that is p. And another one, we can use the x and y-intercept. So how to use the x and y-intercept? X-intercept, so we need to write y equals to 0. So going to substitute 0 to y to find the x-intercept. So x plus 2 times 0 equals 6. So we have x plus 0 equals 6, thus that's x equals 6. So we have ordered pairs 6 and 0. That is for x-intercept. And how about the y-intercept? Let's x equals to 0 plus 2y equals 6. So 10, then 2y equals 6. We need only y here, thus we need to divide both sides into 2. Okay. And then 2 divided by 2 cancel out 2, and 6 divided by 2 is 3. So y equals to 3. Therefore, the ordered pair is 0 and 3. That's for y-intercept. Now, these two ordered pairs, we need this to graph. But remember of this one, in graph inequalities again, this symbol is the dashed line, but different to the shaded part. Again, if this is symbol, we have below shaded line, and this is above. And this symbol is solid, and it's different for this one. So let's have this one graph. Okay, 6 and 0. 6 and 0 is that's for positive x and 0. So therefore that's for x-axis, then the point is here. And for 0 and 3, and the point is there. Alright, now after that, we're going to use the symbol of what line? That is solid line. So this is the solid line. Alright, and then since this is the symbol, we're going to what shaded below or above? So this is the greater than or equal to, so that's above the line. So that's the answer. Since the symbol is greater than or equal to, the boundary line is a solid line. So let's have the activity. Complete the table below by supplying the missing information. So these are the problem, the linear inequalities. Is the boundary line solid line or dashed line? Is the origin part of the half plane? Yes or no? So let's have the number one. 2x plus y greater than or equal to 7. So as you can see, this one we have to greater than or equal to, that is solid line. Is the origin part of the half plane? Yes or no? Yes, because of the symbol of this one. How about the number to the 5x plus y less than or equal to 10? So that is solid line. Is the origin part of the half plane? Yes. For number 3, x minus 7y greater than 15. So it means if greater than, that is dashed line. Is the origin part of the half plane? Yes or no? Yes, because that is inequality. X minus 2y less than 3, so that is dashed line. And half plane? Does of course, yes. So all symbols about the inequality symbol are part of the half plane. How about the number 5? Y equals 3x plus 10. This is equal. There's a solid line or the dashed line. Of course, there's the part of of dashed line. So all the straight line is this solid line. But is the origin part of the half plane? There is no. There's no half plane because that's not inequality symbol. That is for equation symbol. Solve a system of linear inequality into variables. In solving a system of linear inequality into variables, it is very important to follow the steps given. The first one, sketch the graph of the corresponding linear equation. Use a dashed line for inequalities involving greater than or less than, and a solid line for inequalities involving greater than or equal to or less than or equal to. This line separates the coordinate plane into two half planes. The second, test a point using 0, 0 if it is satisfied a given inequality. Point 0, 0 is a part of the shaded region. If not, shade the other half of the plane. The last one, the graph of the system of linear inequalities is the intersections region of the solutions of the two inequalities. Example, solve the given systems of linear inequality x minus y greater than or equal to 2 and x plus y less than or equal to 6. First, we're going to graph the linear inequality x minus y greater than or equal to 2 and x plus y less than or equal to 6. X minus y greater than or equal to 2. So I'm going to use the x and y intercepts to graph this one. So 0 and negative 2 and 2 and 0. So take note, before we graph this one, so y is negative. So therefore, if that is negative and we use the x and y intercept, so do not forget the interchange symbol. So the greater than or equal to becomes less than or equal to. Alright. So let's have this one. So 0 negative 2 and let's plot this 2 and 0. The 0 and negative 2 is here. Okay. So because this is y-intercept. The x-intercepts is 2 and 0, so that's one. Now, since the inequality symbol is greater than or equal to or less than or equal to, so you're going to use a line of solid line. So do not forget solid line. And how about the shaded form? So take note, we interchange the symbol, so it becomes less than or equal to. Why we need to interchange the symbol again? Because of the y. Y is negative. If the y is positive, do not interchange the sign. I do not interchange the symbol, sorry. But if this is negative, so we need to interchange the symbol. So it means the shaded part is below the line here and here and this. Alright. And another one, do not forget this, the graph inequalities. Okay. So next, x plus y less than or equal to 6. So we use the x and y intercept. So as you can see, the y here is positive, so do not interchange the symbol. So let's plot this on the graph. 0 and 6 is for this one. And for 6 and 0 is for this one. Okay, we need to use the solid line because of the symbol. Alright, and then since this one is less than or equal to, so it means that it's below shaded parts. So below is here, not above. So let's shade it. So that is below, not above. Alright. But the problem here, we need to identify the solutions. So for the second step, it says we have to test the solutions 0 0. The 0 0 here is here, right? So I'm going to use another color to see the one. So the 0 0 is here. That is the origin. Now if you're going to test this one here, so let's test. So 0, just substitute minus 0 greater than or equal to 2. But take note, 0 minus 0 is 0, right? And greater than or equal to 2. Is that good? I think that's not. So that's false. Why is it false? Because 2 is greater than 0. So it means the 0, 0 here is not part of the solution sets. Now let's determine again another one's ordered pairs. How about if I'm going to get here? Here. Alright. That is 3 and negative 2. 3 and negative 2. So let's use the 3 and negative 2 here. So 3 minus 2 minus and minus here it becomes positive, greater than 2. So this is false. So remember, this is wrong. So this is 3 minus negative 2, it becomes positive. We're going to change the sign in subtrahend, then proceed to the addition. So 3 plus 2 is 5, right? So 5 greater than or less or equal to 2. So it means that's correct. So this is correct. So it means the ordered pair here, this is the boundary line of the first graph. of the first graph line, and for this one to the second one. So it means the solution here is the solution set of the two linear inequalities. So we need to shade it color blue. So let's color blue. So this is the solution sets, the color blue. All right, so start here. This is the solution because it's the boundary of the two lines. All right, so it means this color blue are the solution sets. So okay, let's test another one for the second. Test a point using 2 and negative 2's and 0 and negative 2's if they satisfy the given equality. Alright, let's do the first one. 2 plus 2 greater than or equal to 2. So that is 4 greater than or equal to 2. That is true. Another one, 2 minus 2 less than or equal to 6. 0 less than or equal to 6. That is true. Alright, how about the 0 and negative 6? 0 plus 6 greater than or equal to 2. That's 6 greater than or equal to 2. That is true. How about the other one? 0 minus 6 less than or equal to 6. That is negative 6 less than or equal to 6. So that is true. So it means these points, or these are the points, is the solutions of the two linear inequalities of two variables. Activity. Identify if the given point is the solutions of the given linear inequality. So let's have the number 1, 0, and 0. So when we substitute the 0 and 0 here, so it becomes 0 greater than or equal to 4. And therefore x minus y less than 1, we have 0 less than 1. So is that solutions or not? So therefore that's not solutions. Y is not part of the solutions just because 4 is greater than 0. Okay, for number 2, does 3 greater than or equal to 4? So how you get the 3? So 2 times 1 is 2, plus 1, that becomes 3. Then copy this one. And for x minus y less than 1, 1 minus 1 is 0. Okay, so this is correct. And is this correct? No. So 4 is greater than 3. So therefore, that's not a solution. For number 3, you have 6 greater than or equal to 4. Okay, we're going to substitute 6, this 2 and 2 here. So 2 times 2 is 4, plus 2, that becomes 6. Then copy the symbol and the number here. Alright, so how about the x minus y less than 1? This 2 minus 2 is 0, less than 1. So this is correct, so it means that is solution. The 3 and 3, just 2 times 3 is 6, plus 3 is 9. So then copy this one, then it becomes 9 greater than or equal to 4. And then for 3 minus 3 is 0, 0 less than 1. So that is correct, that is a solutions. For number 5, going to substitute negative 1. 2 times negative 1 is negative 2. Then we have substitute for negative 1, negative 2, and negative 1 is negative 3. Then copy the symbol and the number. This is negative 3 greater than or equal to 4. And therefore negative 1 to negative 1, take note, the x here is negative 1. So let's write. And then we have the sign, the subtractions, and for y is negative 1. Okay. And then do not forget, we're going to change the sign, and then this one becomes addition. So let's have that technique. Okay, plus. Okay, -1 plus 1. So that is 0. So that is 0 and 1, 0 less than 1. So -3 is not greater than 4. 4 is greater than -3. That is answer is not a solution.